After knowing all the possible effects via the adrenergic receptors of the catecholamines, today I will be throwing some light on the possible mechanisms and routes via which the catecholamines works. I mean to say, we are going in some details of the mechanism of action. Let's commence. Welcome all to his Pharmacology Difficult podcast. I'm your host, Dr. Radhika Vijay, MBBS MD Pharmacology, and this is the audio hub to get the best simplified basic tips, strategies, methods, and lots of ideas to learn better, understand better, and make your concepts crystal clear. If you really find and if there's a question hovering in your minds, is pharmacology difficult? Lend your ears for a while and let in the magic of knowledge. To begin with, first and foremost, let's dive deep and observe nicely, and let's talk about the alpha action routes and the mechanisms. Now, to be very frank, they are actually not very clearly delineated or demarcated, rather they are quite vague. Now, why am I saying that? Because when we get to know the details, we get to find out that most of the post-junctional, I mean to say, that are present after the synapse, they are the alpha-1 receptors. They work via the activated GQ, capital GQ protein, and that leads to the pathway of the increased or enhanced amount of the IP3 DAG. That is one of the pathways of the mechanisms or the action routes. Now, when this pathway is followed, that is IP3-DAG, then calcium is mobilized from the organs inside the cell. Next step to follow is the myosin light chain kinase, that is capital MLCK. It is activated, the myosin is phosphorylated, and finally, contraction occurs. Now, that is the condition about the post-junctional alpha-1 receptors. What about the pre-junctional alpha-2 receptors? On the other hand, the pre-junctional alpha-2 receptors, they stimulate the capital GI protein. You remember the different subtypes of the G protein? The post-junctional alpha-1 receptors, they are working via the GQ protein, while the pre-junctional alpha-2 receptors, they stimulate the capital GI protein. What happens? Calcium channels, they are abandoned. Yes. The cyclic AMP, it decreases in amount. The calcium levels inside the cells, they also decreases. And what about the transmitter status? The noradrenaline, that is a prominent transmitter, it fades away. As far as particular organ sites are concerned, the best one to choose, firstly, let's talk about the gut. In the gastrointestinal tract, the story is something like this one. When the alpha-2 receptors, they are stimulated, the cholinergic neuron, they are hyperpolarized. Less amount of the transmitter. Which one? The acetylcholine transmitter is less released, and the tone of the gut muscles is also decreased. What about the alpha-1 receptors in the gastrointestinal tract? They are found on the smooth muscle cells. When these alpha-1 receptors in the gastrointestinal tract smooth muscles, they are stimulated, there is more of potassium efflux, that is moving out, and finally there is relaxation of the smooth muscles. Coming over to the status of the cells in the pancreas. Now, I know you know that there are two types of pancreatic islet cells. We have alpha pancreatic islet cells, and also we have beta pancreatic islet cells. Now, I'll give you a quick tip to remember. When we talk about the beta cells of the pancreas, the receptors found are the alpha-2 receptors. See, we never find the beta receptors on the beta cells of the pancreas. On the beta cells of the pancreas, we are finding the alpha-2 receptors. So that's a quick tip to learn. I'll be talking about the alpha cells also later on. So alpha 2 receptors, they are found in the beta cells of the pancreas. When they are activated, the cyclic AMP, that is the second messenger, the levels of cyclic AMP, they go down, they are decreased. And what is the result? The insulin release, it is arrested, it is decreased. There is less of insulin releasing. That's a general overview of the alpha receptors. Now, as far as the custom goes, it's very nice to go through the variety of the routes and the mechanisms adopted by the beta receptors. Let's cover them in bullet points, another custom. Firstly, I will be elaborating on the G protein coupled receptor dependent actions. You understand? Dependent means whatever the actions they are taking place to the G protein coupled receptors. First one, generally, when the G protein coupled receptors they are involved, then cyclic AMP is the second messenger. The adenylyl cyclase, which is bound to the membrane, that is activated via the capital GS protein. Now we have talked about capital GQ protein, we have talked about capital GI protein, and now we are talking about the capital GS protein. When these are activated, cyclic AMP is formed from the adenosine triphosphate, that is capital ADP, and a lot many reactions they are occurring in turn to follow. Let's talk about the variety of actions. As far as the liver and the muscles they are concerned, glycogenolysis occurs there, both in the liver and the muscle. Then neoglucogenesis occurs only in the liver, and both of these processes they lead to states of hyperglycemia and hyperlactidemia. What about the potassium status? The status of potassium is such that initial release occurs, and that is leading to hyperkalemia. And then later on there's a long-lasting hypokalemia. And that is a result of the potassium uptake both in the muscle and the liver. So that is about all that is occurring in the muscles and the liver. Let's jump over to the other organ or the site. What happens in the adipose tissues? In the fatty tissues, the free fatty acid level that is enhanced. And the receptors involved, they are the beta 3 receptors that are found on the brown fat cells. Now, their responses they are exhibited in the form of increased production of both oxygen, and there is also increased heat production. As far as the smooth muscles in the gastrointestinal tract and the respiratory tract they are concerned, both they are relaxed. Okay, there's no contraction, there's only relaxation. Now again we are jumping over to the pancreas. I've given you a slight hint about the tip to learn the cells that are found in the pancreatic alpha cells and the pancreatic beta cells. We have talked about the pancreatic beta cells where we had the alpha receptors. Now, let's talk about the other one. In the pancreas, the alpha cells. I'm talking about the pancreatic islet alpha cells. What receptors are found here? The beta 2 receptors, they are found here, they are activated. Now you got the tip now? On the pancreatic beta cells, alpha receptors are found, while on pancreatic alpha cells, beta receptors are found. So they are all opposite. So when the beta 2 receptors on the pancreatic alpha cells, they are activated, there is more secretion of glucagon and more insulin secretion occurs. So insulin secretion is enhanced. Jumping over to the next organ, that is the heart. In the cardiac muscle, there is phosphorylation of both troponin and phospholambin. The troponin phosphorylation, it enhances the contraction of the cardiac muscles due to the interaction of the calcium with muscle fibers. And what happens on the other hand, when there is phosphorylation of the phospholambin, it leads to more activated role of sarcoplasmic reticulum. It sequesters more of calcium and there is more cardiac muscle relaxation. So both the actions, they are opposite. The troponin phosphorylation that enhances the contraction of the cardiac muscles, while the phospholambin phosphorylation leads to cardiac muscle relaxation. Now, more calcium influx occurs as a consequence of activated capital GS protein that interacts with the cyclic AMP second messenger, and all in all, the force of contraction of the heart muscles is increased. Now is the time to discuss the beta receptor actions independent of the G protein. Till now, I was talking about the G protein coupled receptor dependent actions. So, now let's talk about the independent actions. Now, what are the different routes involved? There is signaling via the beta receptors. There are some biased beta receptor agonists. First of all, you need to understand the difference between the dependent and the independent pathways. In the normal course, when the G protein coupled receptor dependent actions they occur, then if the beta receptors they are consistently stimulated, then there is a sort of toxicity occurs and congestive heart failure situation is seen. Now that is due to the consequence of increased workload, and that is a direct effect. Direct means dependent effect due to the G protein coupled receptor involvement. On the other hand, if there is no involvement of the G protein coupled receptors, we are talking about the independent pathway. In such cases, when the beta receptors they are stimulated, there is interaction with the beta Arrestin. What is beta Arrestin? It's a protein found inside the cells, and there is a complex or a duet of beta receptor and the beta Arrestin that is formed. And when such complex or the duet of beta receptor and beta Arrestin is formed, there is no stimulation of the capital GS protein and no further actions are seen. That is, no CHF is settled or ensued. So this is a signaling pathway of the beta 1 receptors, and you can make out the difference. It has a cardioprotective role. So this is an independent pathway of the G protein coupled receptors, and since it has a cardioprotective effect, so researchers in trials, they all are focused on following this independent pathway because it's more beneficial for the heart. So the novel and the new concept of the biased beta receptor agonist, what is that? Let's talk about this novel or the neo concept of the biased beta receptor agonist. The latest researches and the trials, they are based to enhance the production of agonist compounds which act via the beta Arrestin pathway, and there is no involvement of the G protein coupled receptors. And I told you, I have explained you why, so that there is more cardioprotection in this whole pathway. Because on the direct hand, there is a lot of risk of the settling and production of progression of the CHF, that is congestive heart failure. That was quite interesting discussion about these biased beta receptor agonists, the variety of routes, mechanisms of alpha receptors, which were actually more in research since they are not very clear cut, they are quite vague, and a variety of beta receptor pathways, mechanisms, which were really very interesting. I hope you liked this episode as much as I liked talking about it. Till the next one, stay tuned. For all the updates and latest episodes of my podcast, stay tuned to www.ispharmacologydifficult.com, where you can also sign up for a free monthly e-newsletter of mine. It actually contains a lot of updates about medical sciences, drug information updates, and my podcast updates also. You can follow me on different social media handles like Twitter, Insta, Facebook, and LinkedIn. They all are with the same name as Pharmacology Difficult. If you are listening for the first time, do subscribe and follow whatever platform you are consuming this episode. Stay tuned. Do rate and review on iTunes, Apple Podcast. Stay safe, stay happy, stay enlightened.